Okay, type of propellers. And we looked at all the pictures. Excuse me. We had, oops, there we go, fixed pitch, fixed pitch, fixed pitch. That is, of course, is a rigid prop. A rigid prop. The blades don't move, per se. Blades do not adjust.
Unless you have a prop strike.
Yeah, if you have a prop strike, they will adjust a little bit. Don't call me back. Say, hey, I thought you said they wouldn't adjust. They're way out. You can adjust them a couple of times with prop shops can with giant hydraulic presses and twists, and they'll actually twist it into a new shape if you so desire, or put a little more, a little less pitch in it. We had the ground adjustable. The ground adjustable, and as the name implies, the blade angle can be adjusted on the ground. So the blade angle can be adjusted on the ground with the engine not running. Do I have to write that for you? You'll figure it out. On the ground. But I will write this: with proper tools. All right, then we had the two position.
And that ground adjustable, I guess you could adjust it with the engine running only once.
That's yes. Then you will need a new, somebody will have to clean up after you, literally. The ground adjustable, so why would I want a ground adjustable? Well, we talked a little bit about, have my plane, how I want a little more speed out of it. And so, I thought about, hey, maybe I could put just a little bit more pitch in, 1 inch more pitch into that thing. Ground adjustable gives you that option. So let's just say I thought, well, hey, you know what? I'm going to go take a trip down, cross country or something. Well, me in the air a long time. I really want to go as fast as I can. So, maybe I set a higher blade angle, go as fast as I can. Then I get around here and I'm thinking, well, I'm just around here and I want to climb faster. Maybe I'm going to go to Tahoe and I'm really concerned about climb speeds. Then I will take out some pitch and go to a flatter pitch, and that way I have more of a climb prop. And so then I can get some climb out of it. So with the ground adjustable, you have the option to, hey, pick what you want. Of course, then you have to adjust the blades. And you will be doing this in lab, and you're going to find out that it's not hard. It's just a little time consuming to get precise. And that brings you to the two position prop, which was the best of both worlds. The pilot had a control inside the cockpit, and the pilot can select high pitch or low pitch.
Would those change the fuel consumption on the plane?
Well, yeah, it would, I suppose, but that's not usually a consideration at that point.
It's not a big deal.
Yeah, well, not to me. I don't know. Maybe this is somebody else. So two position allows the prop to be in either one, low angle for takeoff or climb, or two, high angle for cruise. Then we had the controllable pitch. Controllable pitch prop. And the pilot at this point, so allows the prop to be in either. This two position is pilot controlled also. So pilot controlled. This one is pilot can control. Pilot can control the pitch of the blades. So in the 2 position, it was just high or low. But in this controllable pitch, you could actually do very finite, little tiny adjustments, like just a little bit more pitch, a little bit more pitch, a little bit less, and you can do what you want. So this particular one that I showed you, so when I reference it, you'll know what I'm talking about. Let me go back to it. Right here from current slide. This right here, this is a beach Roby propeller. So when I say the beach propeller, there are still some Beechcrafts out there with this prop on them. It came in 2 versions, either electrical or little crank. We'll talk about that later. So this is a beach. This is a beach Roby prop. Then we talked about the automatic. The automatic pitch had no pilot input. I'll put that, no pilot input. So we'll say the pitch of the blades. The blades is fully automatic. Fully automatic, based on aerodynamic loads. This is I have it's Compers, K-O, and I might be spelling this wrong, K-O-M-P-E-R, Compers, something like that, aromatic prop. I believe they still make, there's a website that I found at least a year ago where a guy is actually still making the aromatic prop, but he lost his type certificate. So even though this plane did go on type certificated aircrafts, the way I understood it back then, my memory is he lost his type certificate, but he was still selling them for home builds.
Why did he lose his type certificate?
I have no idea. It may not even be anything spurious. Sometimes you lose stuff like that just because the company was sold and the FAA didn't want to transfer the type certificate or something like that. Constant speed. That brings us to the constant speed, which is the modern constant speed prop. So it uses a hydraulic governor. Hydraulic governor to automatically control blade angle. Blade angle. Oh, good. I was going to write a whole bunch more. I think, well, that's not very good. But then I looked at my second line here. This explains it. Pilot sets the RPM, and the blade angle will change to hold the RPM. So once the pilot says, it's the blue knob, once the pilot says that's my RPM, that prop will do prop and governor will do everything it can to hold that RPM exactly where the pilot selected it within reason. So underneath the constant speed prop, there are some options. There is the feathering. The feathering constant speed prop. You just add that. Let me see. I'm going to change this up a little bit. Or we can have reverse pitch, also called beta range. Beta range. We'll talk a lot more about this stuff. So you can add feathering to it. You can add reverse pitch, beta range, which actually reverses the thrust. So the thrust comes forward instead of backwards. That's used for braking the aircraft. Not braking as in destroying it, but used for slowing down the aircraft rather than using the brakes, which I think in some ways is a little silly. I can understand it if you're going in and out of short fields, but to me, the cost factor for putting a reversing propeller on your aircraft, I'm wondering how many brake pads you could buy before it's going to make up for one of those props. I had a customer who had a beach, what do you have? A beach twin. I remember what it was. It'll come to me, doesn't matter. But anyway, I loved flying with this guy. He was one of the most proficient and safest pilots I've ever been in a cockpit with. And, but he had reversing props on his beach, and it was kind of fun because you could back up the aircraft, but it wasn't really all that safe because number one, you usually blast the hangar because you're backing away from the hangar, and two, you can't see behind you, and that's a bad thing. So, Baron, that's what he had. He had a Baron. All right, let's see. Then we had, the last one I had on here was somewhere. Oh, I'm over here. We talked about the test club. And yeah, we'll just make this G, we have the test club. Test club. And that was the short prop that directs cooling air along the engine. So a short prop. They're usually 4 blades, don't have to be. A short prop that directs cooling air. Cooling air along the core of the engine, or I could just say along the engine. Doesn't have to be the core. You want to cool the cylinders. And there we go. And now that brings us to talking about specifically fixed pitch props. Fixed pitch props. And let me see here. I have a video for you. And hopefully you can hear it.
Isn't this just the saddest sight in general aviation? A hangar-bound airplane with the engine ripped out of its nose. Hello, everyone. I'm Paul Bertorelli, reporting for AvWeb and Aviation Consumer. This is our 1938 J3C Cub. We're getting an engine overhaul, and we're upgrading from a 65 horsepower engine to a 75 horsepower engine. And in order to absorb that enormous amount of torque, we're going to need a new one of these, a Sentinich wooden prop. Now, Sentinich still has a pretty lively business building wooden props, and we're going to take a look at how they do it. And to learn how these props are made, we've come to Sentinich, which is in Plant City, right near the airport in Plant City, south of Lakeland. And Don Rao is going to run us through the process of how wooden props are made.
All of our blanks are manufactured from laminated birch. They can have any number of different laminations from 4 up to 6 or 8, depending on the propeller design. The wood is selected based on color and for grain and lack of knots, and then the patterns are laid up and marked off based on the different prop designs. And then once we've selected the boards and they are planed down to finished thickness, then they are laminated using resorcinol. After a 7 to 10 day cure, they are then sent off to the CNC area for CNC machining. After the blank is cured for 7 to 10 days, we then bring the blank over to mill the hub face and bore the bowl holes and the center bore. And that's done in a CNC vertical mill, uses a variety of tools, drills, mills, chamfer tools. So once it leaves this machine, the entire hub will be complete with all the bolt holes, center bore, and chamfers. And the process takes about 5 to 10 minutes depending on the size of the center bore and the number of holes that go in the propeller. After the propeller hubs are milled, then all the propellers are mounted onto our CNC router where we profile the blade shape. And this is done, can be done one at a time or up to 5 propellers at a time. Even though the propellers are CNC profiled, they still need hand finishing and hand work. So the propellers are hand carved using spoke shaves and sandpaper, and we utilize airfoil templates to maintain template fit and protractors to maintain blade angle on the backside of the prop. And all the while doing this, the propeller must maintain a balance and be carved to within a balanced tolerance. After carving, a lot of our propellers actually get a fiberglass covering over them for environmental protection, and this is that operation right here. We use a wet layup system using a 2-part epoxy and a fiberglass cloth that is squeegeed and peel-plied over for application. We use a marine spar varnish for our clear finish, very durable, and will darken to a very nice patina over time. After painting, the propellers come out for final inspection and application of the famous Sensonic trademark before they get packaged into custom cardboard boxes for shipping. Oh, and by the way, we often get asked about that metal sleeve in the center of the propeller. That's actually not a metal sleeve, that is an aluminum pigmented paste that we paint in there to seal the end grain. You can find out more about Sensonic props on www.sensonic.com.
All right. What do you think of that?
Yeah, good video. Didn't realize that that's how they make it. That's pretty cool.
I have to be honest. I am so impressed with those guys who hand work that wood. I have never been I've done a lot of wood stuff with aircraft, built wood airplanes, and I still never consider myself to be much of a wood guy. When I watch those guys making props and filing them by hand, I'm like, damn, that guy's a craftsman. So, okay. So fixed pitch props. I hate it when I do this, but if I don't, so yeah, short video, the video, video. If I don't say that I wrote the video, then I'm off on the whole thing. So fixed pitch props, we have video, wood props. So we'll talk about wood props, There's some interesting things that I learned at my last IA renewal when the prop people were talking. And honestly, that's why I even go to this thing, because I love hearing about them. They always bring some interesting information that's just not out there in the books and stuff. And when they're talking about what's going on with the industry out there, they were talking about the fact that, if you have like a 172, 152, 150, just a regular old fixed pitch prop needs on a prop that's pretty common, they said you're probably looking at somewhere up to a year wait for a new prop. And they said the companies, there's only a few companies left in the world who are producing aluminum, Alcoa, and I can't remember the other names. And they don't want their aluminum used in aviation industry for propellers. And I don't know why they didn't say why, but I imagine it's all product liability. When somebody crashes, you always go for the person that has the deepest pockets. If you have a propeller that parts company with an aircraft or part of it, you're going to go after Alcoa and say, hey, you produced a bad aluminum. So they're very reluctant to give up any aluminum for the props. So they say you really can't hardly get them anymore. So what is becoming more and more common are these composite props, which, like I said earlier, it sounds really, cool, composite. They're really just wood props with some sort of layer over the whole thing. You can't tell that they're wood. And if we were at the hangar at all, we would go out and we could look at the prop that's on our 172, which is an MT prop. And those are becoming very popular. And but the interesting thing about that, which would maybe made me think of this, is their wood. They're going to come up against a wood scarcity because they only collect wood from certain latitudes and longitudes at a very specific altitude. It can't be above something. It can't be below something else. And it all has to do with the sap content. And they figured out that this wood that grows in these regions within this altitude has the perfect sap content for what they need. And when they run out, nobody knows what's going to happen. And we also saw that, you know, when I was back in aviation, looking for wood spars, we built a lot of wood wings, and you need spar wood that has very straight grain. It can't deviate by more than, I don't know, I forget what the deviation is. You guys will get it in second year. I just don't remember what it is. But anyway, that wood was getting expensive and hard to find. But wood props are in some ways still well loved. You can get them. They're reasonably expensive, reasonably inexpensive compared to some of the metal ones out there. So they're kind of cheaper. They're lightweight. They're a little bit of a maintenance pig, if you ask me, but I like that because that's what I did for a living. So originally all props were made of wood. Another interesting thing, the only material known to man that does not have I forget what it is. I should know what I'm going to say before I say it. Fatigue limits. The only material known to man that does not have a fatigue limit is wood. So metal eventually, you know, if you bend it enough times, it fatigues and breaks. Wood does not. It is made of several laminations, laminations of straight grain wood. Straight grain wood.
Yeah, I think he said no knots. That's pretty good.
I know. Yeah, you can't have knots in there. Let's see. Finished to correct size and shape. Fabric. In that video, they put fabric all the way down it. I've never seen that actually out in the field. I've always seen it at the tip. So I'm going to say that tip fabric. Tip fabric is applied to outboard 12 to 15 inches. And the reason why is this reinforces the thin tips. It is varnished. Varnish is actually a big deal on these props. And so I told you they're kind of maintenance pigs. One of the things you have to do is you have to really pay attention to the varnish on it. And when they need to be revarnished, you have to revarnish it. But when you do it, you have to absolutely make certain that you apply the same amount of varnish to both sides, and you have to balance it when you're done. And if you have one side that is a little bit lighter than the other, you add more varnish. And so you have to do that. The other thing, I don't think I have it written down here, but the back of the prop, which is really called the face. So the face of the prop, the part that faces the pilot, if you notice, they spray painted it black, but it has to be flat black. It cannot be any other color than flat black. And the reason why, and I learned this in a funny way. I had a customer, actually at the Lodi airport, who had a crop dusting service, and his airplane got away from him just a little bit, and he ran through a barbed wire fence. And it did not do nice things to his propeller. It really scratched. So he called me up and he's like, hey man, on your way home, could you bring some files? I got a couple of little nicks in my prop from hitting something. And he said, oh, and bring some flat black paint too. I got really sick. And so well, that was weird, you know, statement. So when I got there, and he goes, dude, man, I got flicker vertigo super bad. And I said, you got what? And he said, flicker vertigo. And I had never heard of that because I was not a worldly person at the point that time. But anyway, as he explained it, he goes, you know, back in the old days when they first came out with motion pictures, you know, they would flicker. They didn't show them at the same rate that we see them now. and they were experimenting. So it would flicker as it would go through all the, you don't have to go away, Eric. So it would flicker, and people in the audience would actually get sick from this. And so what happened to his name was Koppel, I forget his first, Jim. What happened to Jim is when he went through this barbed wire fence, it scratched a bunch of the flat black off of the face. And so he's flying around spraying crops, and the sunlight is hitting that and flickering. And it caused him to get really sick. It's like, it's a vertigo. You know, vertigo is, so you got vertigo from it. So anyway, I showed up with all my little jeweler's files and some flat back paint. When I looked at that prop, it was like, holy crap. It was not an airworthy sign off at that point. I'm like, I can take the chips out, but dude, you need new blades. So they were pretty bad. So, okay, so yeah, they're varnished, and varnishing is part of what you do. Metal tipping is installed to the leading edge. I'm going to move over since you probably all wrote that. Actually, everybody got that? Good. I'm going to erase this file. Edit. Clear. All right. Metal tipping is applied to the leading edge. Metal tipping. That's something you're going to see on any kind of, or any prop that's not metal. Any sort of composite prop, whether it's the wood composite, it's a graphite, what's what I'm looking for, fiberglass composite, carbon fiber composite, they all have some sort of metal tipping. The wood props, it is the most secure. It is really part of the prop. All of the other ones, most of them, it's some sort of tape that's actually taped on. It's not even that uncommon to see a tape starting to come off. So the metal is brass, stainless or Manel. Or Manel. Protects the leading edge, protects the leading edge from rocks, chips or screws or FOD, whatever's laying around. These are some Q&A questions right here. I'm pretty sure of it. It's attached with countersunk screws. In the thick sections, in the thicker, that is the thicker sections of the wood, and rivets in the thin sections. The screws are safetied with solder. And finally, small, that'd be about number 60, which is really small, holes, that's supposed to be are drilled into the metal to allow moisture to escape,
Kevin, quick question. On number 4,
Yeah.
screws are blank softened, or what was that?
Safetied.
Safety, thank you.
And what are they soldering the screws to?
The metal tipping. I don't think
So it
close
just,
up.
I guess, becomes one thing, huh?
That's it. If I had a close-up, I don't think I have a picture of a close-up of a wood prop.
Wait,
So-
this is a stupid question. But like safety with solder, you mean like you melt the solder onto the screw, right?
Yep, onto the screw head, which
Oh, okay.
then the solder basically welds itself to the metal tipping, and then they sand it smooth. So when you look at it, you're going to see,
It's just going to look like it's on there.
well, you're going to see a dot of solder. Here we go. This might work.
Yeah, because when you first said it and then I wrote it, I was like, wait, so instead of using safety wire, they use solder? Wait, what? But
Yeah.
okay, now I get it.
This isn't a real high resolution photo, but you can see all those little dots. That's where they put the countersunk screw. Then they put the solder on it, and they put the varnish on top of it. But then down here where it's real thin, they just use rivets, and then you can see little tears right there. Those are the drain holes. Those are those are bigger than 60 right there. And then this green right here, and I don't know why it's green, but it's always green, is the fabric.
So I have a question. I think we're gonna go over it maybe in aerodynamics, but frost. I know like frost is a problem for wings. Is it a problem for propellers too?
Oh yeah, not frost, but icing.
What does it
And-
do?
It builds up on the prop and it completely destroys the aerodynamic properties of the prop to the point where it's just a piece of ice floating around out there, and that does not help you at all. Let me see. Pull this one.
Kevin,
Yeah.
how much is a wooden prop? What does it cost?
I want to say about $2,000. Bruce, let me see.
With those, like in the video you watch, they put the sticker on at the end. Do
Yeah.
those stickers have to go in a certain spot on each side to keep the balance?
They do, yeah. I don't think the sticker's quite that critical. Let me see.
Where do people get their wall decoration props, like broken ones and stuff?
They sell them on,
From school?
yeah, from the school. They just steal shit. Here we go. Sensenits for Ronca, $1,900. Cessna 120, 140, 2,900. Luscombe, Piper. As opposed to, let's see.
You could almost buy a Tiger for that much.
Sensenich metal. I don't even think they give a stinking price on here. Cessna 150. Yeah, they don't even give me an option here.
Call for pricing.
I think it's like, does it say call for pricing on here? I think it does. Yeah, you got to call for pricing. It's like, best of luck to you. These are, this is home built props. There we go. That's a home built, non-certified home built prop. So for an RV, so 4,700 to 5,100. 0235, 0320. So again, non-certified.
There you go, Zach. That's pretty well.
So you're probably double that for conventional or certified. Okay, small. So what else can I tell you? I don't have this in my notes, but or maybe I do later, and then when we get there, I'll just say, well, I told you about that. So I have a lot of customers with wooden props, but I had one client in particular who had this paranoia about him of having to ever replace his wooden propeller. And so he treated this propeller with the most kind and loving care of anything I've ever seen in my life. And sadly enough, he died in a different aircraft, and he sold this aircraft to somebody. And this person ran that prop up right up the back of a BMW and turned it into 1 billion little toothpicks. But anyway, so he kept his airplane in a shade hangar, and he had a sailmaker, but it was out on the Delta. So he went to a boat guy, and he had boat canvas sleeves made up. So every time he was done flying it, the blue canvas, he would put the blue canvas over it. And he did it right though. One of the things you have to do is you always have to store them horizontally. If you ever store them vertically or in any other place besides that, the moisture will collect in the lowest blade and cause an imbalance. And so he would always be very careful to put it very horizontal. And and he would have me retorque it probably every single month. Every month I would just get a call. Hey, Kevin, need you to go retorque my prop. And what I would do is I would go out there and relax all of the bolts and then torque them back up. And I don't remember offhand the torque, but I want to say the torque on those bolts was somewhere around 100 to 200 inch-pounds. Very, very low. And the reason why he would have me do this, and is because I talked him into it. And the reason why I talked him into it is because, especially out in our area and where we were right next to the Delta, I mean, his plane was literally, 50 feet from the river. It was just on the other side of the levee. His tail was actually right at the levee. So you just walk up it and across to the river. So we were in a high moisture environment. And so wood, when it gets moisture, it swells up. So what would happen is if the bolts weren't checked and we had an environmental change, the wood would swell up, which then actually makes the bolts tighter. And it would cause the plate that you torqued on the bolt to dig in to the prop. And so you know what it's like if you're building something, you guys bolting something to wood, it just kind of collapses into the wood. So it would collapse into the wood. And then we would have a period where we'd have hot days and wood would dry out. And now the wood is smaller there. And so the wood would be loose. And so if you flew it, you'd have this vibration where the wood is actually loose on the hub, which would cause the holes to wear out, which means you have to buy a new prop. So, and the opposite is true. If I happened to torque it where it was wet, and then when it dried out, it would be just loose. So, but it wouldn't damage it. So I'd always have to go out there and retorque it every month. But the torque is really, really low on these things. It's surprisingly low. And of course, when you torque it, it is critical that you use a star pattern. If you've got the bolt, let's see what I got here. There we go. Let's look at this one from current slide. So if you were to, I've seen this a lot of times, and it's fine. You can do it once and then you throw the prop away. People would torque it. And what they would do is they would look at and say, okay, first mistake is, well, it takes a half inch wrench, so it must be a half-inch bolt. So then they go to 4313 and look at the half-inch bolt torque, which I don't know is several hundred inch-pounds, and they'll torque this to 350 inch-pounds, then this one, and most mechanics, by the time they get to about this one, will realize something is horribly wrong, as they have smashed this end of the prop, and this plate here is bent and twisted, and so is the hub. And at that point, they realized they just bought a prop and a hub. And so then the customer would usually take their airplane to a new mechanic. And the new mechanic would know that what I would do is I would torque it to like 25 inch-pounds, which is the lowest my little torque wrench would go to. And you do this one, then this one, and like this one, and this one. Do a star pattern. They're always the furthest one away. So that one, that one, that one, that one, and that one. There we go. So like that. So you are evenly doing it. So I would do it to like 25 inch-pounds, then 50 inch-pounds, then up to 100 inch-pounds, and then my final torque. So I would do it like 4 or 5 times until I got it right. And by the way, prop bolts on wood props going backwards. They don't go in the right way. So if y'all was looking at it right now, I'd be looking at the nut end. The bolt comes through the back. So this is the nut. So it's completely and totally backwards from what you would think it would be.
So when you were doing that for that guy every month, would you have to use new bolts or what?
Love that question. I wouldn't, because at that time period, you didn't have to. But now, I forget, it's Macaulay. I think it's Macaulay or Sentience. I forget. I've got to look it up, because whenever you take off their props, one or the other, and I don't remember which one it is right now because I haven't taken a prop off in a while, you have to either Magnaflux the bolts or buy new ones. And they're like 150 some bucks a set, some crazy number like that. So this is the hub, and I've showed you guys this before, a hub that goes on a taper shaft. So most of these wood props go on low horsepower aircraft that usually have a taper shaft. My customer had a 65. Actually, we did the conversion for him where they said at the Cub, they were converting it from a 65 to a 75. I did that conversion to him on his Aranca. And oddly, it takes two things. You change out the pistons, which requires a different piston pin. It's actually smaller. I don't know why. So it's different piston with a smaller piston pin, which means you have to rebush the rods. And then you just placard the RPM for a higher RPM. And there you go. So 75 horsepower. But anyway, see, the bolts are coming through backwards. And that's because there's very, very little clearance back there. And if you were to turn them around and put the nut back there, the bolt would dig into the crankcase and make a mess of things. But I know we've talked about this particular thing in class many a times. So, all right, so where am I at here? Metal tipping small. That's really all I have to say about that. That's the wood prop for you. So things to remember, store them horizontally. Yeah, things to remember. Things that I didn't write down, store them horizontally. I must say it somewhere. I think I do. And torque carefully. All right, so that means I'm up to 13 metal props. Metal props. Aluminum is the most common. Aluminum is the most common.
We got a video for that?
Nope. Wish I did. They do make, I'm not aware of any steel props that are fixed pitch. The only metal ones I know of are ground adjustable. And they weren't, you gotta be careful with them because they had corrosion problems and they're hollow and yeah, be careful. So, all right, there's my fixed pitch. This hat up front here, that is my spinner, a very expensive piece of metal.
That's a nice ass airplane.
Yeah, it is. Now that would be a 172. And the only way that I can tell them apart, because from a picture, is that a 172 has a fixed pitch propeller and a 182 to me looks exactly the same, but it has a constant speed and usually two exhausts and cow flaps. And other than that, they're just bigger. Aluminum, most common. So what are the benefits? Benefits of aluminum. They are thinner than wood. You're limited to how thin you can make the wood just because of strength properties. Therefore, because they're thinner, it makes a more efficient airfoil. More efficient airfoil. Because they're thinner and they have a more efficient airfoil, you get better cooling. Better cooling, engine cooling that is, due to airfoil shape, airfoil shape near the hub. And speaking of airfoil shape and engine cooling and all that, this spinner up front, that is not an option and it is not there to make the airplane look cool, although it does help. That is actually part of the cooling system to get air to come in and go inside the cowling. So I've never flown an airplane that was supposed to have a spinner without one, but I would believe that it would actually get a little hot. So less maintenance. Just because of what I told you, you don't have to worry about them being horizontal. You don't have to worry about retorquing the bolts all the time. Although I do believe that FAR 43, Appendix D, the appendix with the 100-hour annual inspection, does say that you are supposed to check the torque every year. Let me see, less maintenance. And this is something I talked just a little bit about yesterday, part numbers. You will, let me see, I'm gonna do a Macaulay and then you're gonna do a Sensenich in lab. And so you'll get the books to do it in lab. So part numbers. Example, if I had a Macaulay, if I had a 1 Bravo 90 Charlie Mike 7144, and there's usually a little space between those right there. The 1 Bravo 90 is the model number. the CM designates the style. I should say hub style, which may have the mounting hole. I don't want to say that. I'll say mounting hole dimensions. Like how far apart the holes are spaced, what size bolt holes they are, stuff like that. I also believe it has something to do with the tip style. The 71 is the diameter, in inches. And the 44 is the geometric pitch, in inches. So for one revolution of the propeller, you should theoretically go 44 inches forward with the aircraft in inches, at the 75% station. Be specific. But we know that you're not really going to go 44 inches. You're going to go 75% of that probably. And let's see, example. There are typically different prop versions, versions allowed for each aircraft. As listed on the TCDS, Type Certificate Data Sheet. And then with each version, within each version, there is a static RPM tolerance. There is a static RPM tolerance. And this is exactly what we talked about yesterday. I just didn't know that I was going to do it. I forgot. And I even have the same thing we looked at. So the Cessna 150 is allowed to have 3 different propellers. So, and within each propeller, notice that it doesn't give me anything about the length or the pitch, nothing at all in the part number. It just simply says not over 69, not under 67.5. And of course, the reason why it can't be over 69 is you know that we're going to get into problems with clearance issues with the ground. So it can't be over 69, 69, 69. It's the same for all props. And I would surmise that it can't be under a certain limit simply because if you get under it, then you've got to pitch it so much to try and get the static RPM limits that you're actually kind of messing with the efficiency of the propeller and some other things in there, which I believe have to do with vibration and stuff, possibly. So within that, so there you go. And I have 1 minute left. So there are RPM tolerances. That's probably a good thing to say. Let's finish this one. So I'll say this. So props are often pitched by about 2-inch differences to create 3 possibilities. So I'm going to tell you those possibilities. 1, we could have a climb prop. It's really good at climbing, climb prop, which is going to give me the highest RPM. I'll put static RPM, highest static RPM. And then I could have a cruise prop, which would give me the lowest static RPM. Or I could have what I believe most props come out of the factory with, just a good all-around prop, which would be a middle static RPM. All right, there we go. It is time for some food.
Yay.
I know.